All right. Welcome, everyone, to the September 30th, or the month of September community call for the NetBox project. I am Jeremy Stretch, the lead maintainer of NetBox. Joining me today is Darren Fulwell from IP Fabric, who's going to be leading us through a quick demo showing how we can integrate NetBox with IP Fabric. So, really looking forward to seeing that. Thanks, Darren, for joining us today.
Pleasure to be here. Thanks for inviting me.
Absolutely. And just before we get to that, we got a few quick community updates I'm happy to share. So we do have a new maintainer joining the team. I also want to call out the latest release of a Terraform provider for NetBox, which is really exciting. And as always, a few community highlights and a bit of Q&A. So first off, thank you very much to Jonathan Senecal for joining the maintainers team. He officially became a maintainer on September 1st, so we actually just missed him on the previous month's call. But yeah, he's joined the team. He becomes our fifth maintainer. Jonathan comes to us from the community. He's been involved in the project for some time now, and if you've been on Slack or GitHub, I'm sure you've seen him around. He's got a few of the 3.4 milestones, assigned to him as well. So really interested to see how that works out coming, the next month or so as we move toward a 3.4 beta release, which should happen around mid-November. Jonathan says his personal mission is to make things, fix stuff, and help others. He just happened to love working on high-tech stuff, so it became his area of expertise. So again, thank you, Jonathan, for joining, and welcome. Next up is a project that's become of interest lately. The project's name is Terraform-Provider-netbox, and as you'd expect, it's a Terraform provider for NetBox, managed by E. Bruniger under that GitHub organization. They recently had a version 3.0 release to implement support for NetBox 3.3. It was delayed a little bit because of some work that was going on with NetBox Docker. I don't remember the details of that, but basically that became unblocked, and then two individuals, Fabian Breckel and then Antonio Pellegrino, or Pelli, as you know him here at NS1, were able to continue work on that project and facilitate the version 3.0 release of the Terraform provider. So if you use Terraform, by all means, go check that out. We've seen a few providers kind of pop up of varying degrees of maturity and complexity, but I dare say this one's probably the most mature, not having taken a firm objective look at the others, but this one seems to be the most active. So check that out if you're interested in Terraform. Next up, a few highlights from recent conversations on GitHub and Slack. So two discussions of note. One of them was 10446, which is the interesting question of how to model wireless access points that they appear as you'd want them in cable traces, which is interesting. I know it sounds kind of oxymoronic, right? Why would you have a cable trace from an access point? But we can actually trace paths across wireless links. So interesting discussion there if you're curious. Also, kind of on that vein, plugin development and logging. There was a discussion around from someone who's building a plugin who was curious about, well, how do I enable logging? And there's some good back and forth there that it kind of I think exposes a lot of the very common concerns and kind of challenges that plugin authors face around, how when you're integrating with another tool versus just working on your own project, how do you facilitate things like logging and debugging to make troubleshooting easier? So there's some good tips there, which we probably should go back and extrapolate or extract rather into some of the plugin development documentation. Some other issues of note recently. 10500, which revisits the idea of nested modules. So if you remember, I think it was NetBox 3.2, we introduced modules that can be installed, modules and module types. So you have modules that represent essentially like line cards in a chassis-based switch that can be installed in devices. This revisits the idea of nested modules for things like where you have a router that's got it's got a line card and it's got like separate modules inside that, and each of those modules then has different interfaces on it. I think that one needs a lot more discussion and thought around how that would work if we take that on. Another issue of note is 5285. So this one's been open for a while, and it deals with something that's not very direct, or I guess obvious in the way you might model that. So this is, if you've ever seen an equipment rack that has slots carved into like the sides of it, so not the normal rack units, position 1 at the bottom, 42 at the top, or what have you, but kind of like these ancillary slots that just kind of appear elsewhere randomly in the chassis. The question is how could we model that? This is not to be confused with something like a vertical, like a 0U PDU, which just kind of bolts to the side of the rack and doesn't actually take up a slot anywhere. This is kind of like this weird sort of niche that's out there. So if you have any familiarity with that or any strong opinions about how we might be able to do that, let us know. Again, that's issue 5825. And finally, there was an interesting conversation just a few days ago on Slack about modeling MPO cables. This is probably a good one that we'll have to revisit, because a lot of people are stuck with this idea that NetBox, prior to NetBox 3.3, MPO cable modeling wasn't ideal. It's gotten a lot better now that we have multi-termination cabling in version 3.3. So you can actually have, one interface on one side mapped to 4 different interfaces on the other side. If you're modeling, for example, an MPO cable that's taking 100 gig Ethernet and breaking it out into 4 discrete 25 gig channels, each connected to a physically different interface. And that's on Slack. That was a few days ago. Unfortunately, we don't have a way to link to a Slack conversation very easily, but I'll drop a link in the comments if I can figure that out. All right, and another real quick one. Typically, we'll do this at the end of a call, but because we have Darren here all prepared for a demo, I want to knock this Q&A portion out very quickly. We just had one question in for this call. This comes from Jake, who asks, is there a plan to add L3 VPNs such as IPsec and GRE tunnels? There's not necessarily a plan right now, but there is a feature request for it. So that's number 9816. Hasn't gotten a lot of attention yet, which is surprising because this has definitely come up in conversation many times. There's some debate as to whether or not that should exist in core versus being a plugin. I myself don't have any strong opinion either way. I think it's something we should at least consider implementing in core. However, we'll need to do put a lot of thought into how we can best do that. I will say one thing that's different about the conversation now is that we have, as of NetBox 3.3, we implemented L2 VPN. I never remember when we do stuff anymore. Like, it all just kind of blends together. I'm sorry. But now we have the ability to model L2 VPN overlays, which will probably inform somewhat, how we could do more traditional tunneling. So we're kind of doing that backward, I guess. But it helps kind of, we've now defined kind of the barrier around that scope or the feature of L2 VPN. So now we can kind of see what's left and what might make sense to extend in the L2 VPN model versus introducing something else for like discrete point-to-point tunnels. Because when you do get into things like L3 VPN, it gets a little wonky as far as what constitutes a tunnel versus an overlay and so forth. So at any rate, that's a great place to have that conversation if you're interested in that kind of functionality. All right, I've talked enough. So now I'm going to hand it over to Darren, who again is visiting us from IP Fabric, who's going to talk a little bit about IP Fabric and how you can integrate it with NetBox to in support of your network automation goals. Darren.
Thanks very much, Jeremy. It's interesting. Some of the challenges that you've talked about there are things that we all see all the time, I suppose. How do you manage and handle things that are slightly outside the model that you already have, and how do you introduce new aspects? And certainly tunneling, that old problem that never goes away, right? That's regenerated time on time. But it's really interesting discussions I can see you guys having there. So interesting to hear the results of that. And I suppose this is part of where we come in, because one of the things that we're doing is having conversations like this all the time with our customers. And one of the ones that keeps coming back and gives an awful lot to us is questions around the data, how that data that for NetBox, where it comes from, and how you do that initial population of NetBox, they get that information from your network into it. And then how you keep it up to date and use it for things like measuring the success of delivery of change and that sort of thing. I mean, if you think about it, there's a few things that we need, pieces of information we need to gather and to use to sort of deliver that. And what IP Fabric calls that process is network assurance. So I'll walk you through very quickly what we're talking about when we're talking about network assurance, and then how that can be used to deliver an outcome for you in your network automation journey, I suppose. The idea of network assurance is to make sure that the network is doing the things you intend it to, right? By fair means or foul. So currently, that means for people who aren't automating, using documentation, using tribal knowledge, guesswork, fragmented manual processes and tasks to basically go and prove this out. The first aspect of is the inventory. It's to know what it is that's actually there in the network, and actively making the network work. And normally, if you want an inventory, you're going to go hit up a CMDB or a spreadsheet or whatever that's been updated when all those new devices are installed or decommissioned, if you're lucky, right? I mean, most of the time, that's you'd like to rely on that, but I don't know anyone who'd rely on that 100%.
Absolutely. Yep.
Yeah.
It's always which spreadsheet, right? Which
Yeah,
version.
right, exactly. Or I've got a spreadsheet for this and a spreadsheet for that part, but I've not got a spreadsheet for this part. That's in somebody's head somewhere, right?
Yep.
And then I suppose you've, on top of that, what you've got is the intention for that device, the thing that you want that device to do, the configuration, right? It's all about saying, do I have templates? Do I keep config backups? And where does the configuration come from? And is it the configuration I want it to be? Again, similar problem, because you're likely to have, I don't know, you may have a Git repository somewhere with all of your access switch configs in, but your SDN platform might have the information in the controller that's not tracked in the same way. So you've got multiple places to go look at this stuff. Now, one of the other interesting points of that is that a config is that intended state, and this all sounds familiar, right? Because where netbox is the intended state for your network automation, so a config file on a device is the intended state for that device. So there's always the operational state of that device, which doesn't necessarily reflect what's in the config, right? Because a network is a distributed system. It's lots of things talking to each other, and things can have unintended consequences. So you want to be able to see the effect of that configuration on a device, and is it what I expect it to be, based on the fact that there are other influences surrounding that device. So this is the state information, and normally state information isn't something that's kept. You'd normally, if you wanted to find out what state a device was in, you would have to go and look at that device, either by logging into it and running a bunch of show commands, or by going to a monitoring platform and looking at the individual data points on there. But what you're not getting is that sort of consistent view, that detailed view that may be giving you the information you need. So always a struggle then to map that state back into a point in time with the configuration and with the inventory of the devices in the network. And then, of course, the next step is the topology, because obviously the way that devices interact educates all of these things, right? How do you know which devices are connected to which? How do you know how traffic is going to flow through a network without understanding the topology at multiple layers, right? You've got the physics. I mean, you were talking before about cabling in the model, right? But you've got layer 2, you've got layer 3, you've then got your tunnels over the top and all that good stuff. You're going to have potentially multiple diagrams of multiple parts of the network in order to put all that together to understand, is the network actually doing the thing it should do? So that's probably the most complex bit, and of course, it's the bit that every network engineer loves doing as well, right? Diagrams.
There's the different layers as well, where people say, "I just want to see a drawing of the network." Well, we have to. Oh, at what layer do you want to see? Layer 1, layer 2, layer 3, right?
Right, and which part of it, right? Because a network isn't just one network, is it? It's a network of networks that's delivering an application from one end to the other. So, importantly, you need to understand that whole end-to-end view of all of the parts of the network and how they all interact and build your the support for your applications, because ultimately that's what we're trying to do here, right? Is deliver applications so that the business can carry on doing the thing it needs to do, and carry on making the money to keep on paying us, right? So that's the point of why we're here. So you've got lots of different tools, you've got lots of different processes, loads of different information buried in people's heads, and varying levels of detail available depending which part of the network you're looking at. So it's really tough to get a consistent view across the whole network and understand it all in one place. Which, if you think about it, if you're trying to then take that data and put it into a source of truth, you need that consistent view, right? It needs to be the same for each part of the network that you're pushing into that source of truth. So the consistency is super important. So what the network assurance tool will do is go to those devices. It discovers the network itself the same way that you or I would. If we were to sit in front of a switch and work out how we discover the network, we'd look at the MAC address tables, we'd look at spanning tree, we'd look at routing tables, we'd look at and understand how to crawl through the network in order to deliver the topology and the information about that infrastructure. So this is what IP Fabric does, right? It goes and does it in exactly the same way a network engineer would, gathering that inventory data as it goes, gathering the configuration data as it goes, pulling information about state, and then modeling the behavior of the network. So it strips out all of the vendor specific stuff. It creates this vendor neutral model of the network so that you can understand how the network is going to behave from one end to the other, and you can get a consistency of detail depending regardless of which vendor kit you're using or which part of the network that you're looking at. And once you've got all that data, you can then start to do the topology stuff, because ultimately a topology diagram is just a representation of all of the relationships between all those devices, right? There's enough data in the devices themselves in order, once you have the model, to build those topology diagrams automatically. You never need to touch Visio again, right? And once you've got to that point of operating the network, so what you're creating is this self-documenting network. It's the thing that people always used to say, why would I have documentation for my network when the network documents itself? Right?
It's like self-documenting code. Like, it's just read it, you'll figure it out.
Right, exactly that. The only problem is, of course, things are so complex now compared to how they were back when I started doing networks, when they were like, daisy chained devices, servers with PCs in an office, and that was the extent of your network.
Yeah.
Things are a little bit more complex these days. So you need something to go do that for you. But the rules are the same. It's just it needs to be done in an automated fashion so that you're able to bring all that to bear. And that's the point here, right? This end-to-end capability of being able to stitch together a data center infrastructure that hooks to the cloud, into a WAN, across that WAN into a campus network, to the wireless network, and be able to understand, right, how does a user over here get to that workload over there? How do we show all that? So the beauty is that once you've got all of this information, you can start to ask exactly some of those questions. And I'll just give you a quick look at some of that now. The first thing might be, what devices have I got? Where are they? And what code versions are they running? So we have tables like this in IP Fabric, which give you that level of information, right? You've pulled all this data out of those devices. In this case, we're using, what are we using in this lab environment? We've got right, it's all Cisco devices, but they're a mixture of ASAs, Viptela, there's switches and routers, and there's some Azure stuff in here as well. And we've just pulled all this information, normalized it. As you can see, these are the same columns for every type of device that we've got, and this would be the same across all vendors, and created this table. And the beauty of it is, once it's in this table, we can manipulate it in the same way you would an Excel spreadsheet. You can sort, you can filter, you can do all of those things. You've got all that view straight away. You might then ask, well, what does the network actually look like, right? I can see all the devices, and that's great, but what does it look like? Well, here's a quick example. This is a topology diagram of that same data we were just looking at, based on the interactions between these devices. So if I look, for example, at this head office location here, you'll see blue lines representing spanning tree neighbor relationships. You'll see green lines representing, in this case, it's CDP and LLDP. Now, I might not be interested in the physical stuff. I might just want to turn that off. So I can turn it off. I might want to dig into the spanning tree and actually identify a VLAN, a specific VLAN in here. Where is that one that I was looking for? Oh, VLAN 182 will do. Let's have a look at that one. We'll turn off the spanning tree itself, and we can dig into. Right, there's VLAN 182. So this just shows you instantly just the information you're interested at point in time. So your point before of having all the separate diagrams, in this case, what you can do is you can just select the bit that you're interested in, and you've got the diagram. You can, if you want to, you can export it as a PNG or an SVG and use it elsewhere. You can even pull it out over the API, but we'll touch on that again in a bit. But the point is that this is completely dynamic. As you learn more parts of the network, so that they'll appear in the diagrams, you can lay them out the way you want them to and just share them. And this is all based on this behavior that we've tracked through in the database. For example, how's OSPF configured? What state is it in? Right. Well, if I just bob down here to the OSPF table, there are my OSPF neighbors. Here's the config information on one side, so which host names and interfaces are configured, what the local area number is, and the cost. And on the right-hand side, I've got the state information that relates to that. So I've brought together both the config and the state from that circle in one place. So I can now check and make sure that these are the way I would expect them to be. And you see all the color coding that's going on this table here. This is overlaying information about that intent onto the table, so we can see whether things are as we expect them to be. Great example.
That's where you're doing that assurance, right?
This exactly that. This is where the assurance. So it's kind of three phases, I suppose, of what IP Fabric's doing. The first is the discovery piece. The second is the modeling in order to get those relationships, and the third is the assurance engine, which is basically overlaying all this other intelligence over the top. So in this case, yeah, this state column here, for example, this is this rule at the top here, and actually this is all good, right? Because everything is in a full or a two-way or an attempt state, which is where we want it to be. Nothing is currently down, which is all good. But you will notice there's another rule here where there are some numbers that aren't quite right. So cost consistency on the interfaces at either end of a relationship. In this case, most of them are okay, but in some cases we've got 6 here where we've got a mismatch between the local and neighbor cost. Now, all that's actually going to do is give you perhaps a little bit of asymmetry in your routing through the network, but it's an undesirable state, right? And so we want to go ahead and fix that. So to be able to identify that sort of thing very quickly, globally across the network, it shows the power of having the data there.
Sorry, I just have to call out how you just kind of hand wave just a little bit of routing asymmetry. It'll be fine.
And in most cases it is, of course, right? But there are cases where it's really, really, really not. And so
I just joke because I've spent many hours, trying to figure out.
Well, of course.
But yes, absolutely, it's definitely something that you'd want to check.
Yeah, I mean, if you've got anything stateful in the network, that particularly firewalls, that type of thing, and these days, SD-WAN as well can be interesting. If you've got any asymmetry in there, you're lining yourself up for problems. I mean, my example that I love using on here is MTU mismatches, because we have that ability as well. It's very similar. We understand the links. We understand what MTUs are at both ends. And if that MTU mismatches, well, one thing you'll know because your neighbor relationships won't establish. Yep. But what happens when you run an overlay over the top of that? Because, of course, in one direction it will work fine. In the other direction, it's not going to work very well at all. And you're going to end up losing things. And I've had some horror stories around overlays and MTUs, and I'm not going to go into those right now because I'm sure everyone's had the same. But being able to spot it like that very quickly, super useful. The last case I'll show you very quickly here is bringing it all together, really. Let me just kill off one of these. this is the ability to take all of that information and understand a flow of traffic through the network, right? So in this case here, and I'm just going to switch. Oh no, I won't switch. I'll just try an echo request between these two points. So what we've got here is we've got this simulated model of the network. We know where the endpoints are, and if we plug those endpoints into this path lookup capability, what it'll do is it will show us exactly what path that's going to take to get from one end to the other. So in this case, I've got a colo location here with some routers and switches passing into MPLS across another site here, into a firewall, across a VPN into Azure, right? So it's a pretty complex path. What we do is at every step we understand how the device behaves, and so whether it's going to actually forward traffic and move it through the network. And so we have an example. You'll see the firewall is showing green here because we take a bit of an extra step with anything where policy's deployed. We can show the packet in, the packet out, and we can show any security policy that may be either allowing stuff or blocking stuff through the network. So in this case, I've got a nice green unlock to lock here next to this ACL, and it's allowing traffic through. If I were to switch that to a web request, for example, say someone's rolling something out, you'll notice that firewall's now gone red. Okay, not only has that firewall gone red, but then my lock is now locked, and that ACL is now showing as deny, right? If I click through on the ACL, you can see that ACL is actually only allowing ICMP through here anyway. And so, the ACL needs a change. So very quickly, we can use that path lookup to say, has a change, for example, or is an application going to work after the state of the network has been checked end to end? Really important point, because the way that IP Fabric works, it creates these models on a snapshot basis. It's doing this over and over again, whether that's once, twice, 3, 4 times a day, whatever it is. We'll go ahead and we'll build this snapshot. So you can query the snapshot and use it as a checkpoint almost to say it was working at this point and it's not working at this point. What's changed, and how's that actually going to affect the behavior of the network?
That's very cool. And just to reiterate that point, so when you are doing the walkthrough, like triggering the ACL, for example, you're not doing that on the network. You're not actually sending a packet out of the network. You're running. You're saying, if I were to send this packet, and then evaluating all the rules against all the data that you know that you have cached. Correct?
That's exactly that, right? So this is basically so this is stopping here because I've got this set to drop here. If I step back a level, I'm now on this switch. You can see that the input is from the other switch from the right coming in. I'm going out towards the firewall, and in this case, it's a MAC address table match that's allowing that through, right? If I go back a step again, I've got a routing table match, and then an ARP entry, and then a MAC table match in order, because it's a layer 3 switch, and so on. So I've got every step of the way. I know exactly what information to look at in order to show that it's going to progress through the network the way I expect it to.
Yeah, very cool.
Which is great. And again, this information is all available over API, right? You can make a simple. I say simple. There's a lot of potential data that you would feed into a request payload, but we give you it, right? So here's the API endpoint. Here's the request payload data that you feed in, and that's the result you would get. You would either get that as an image or as a JSON data structure describing that path. So you can then go and dig down into it in more detail, go and do some interesting stuff with it. So you can see, right, as an interactive tool, this thing is awesome from a network perspective. It looks great. It has all the information in it you could possibly need to really create that self-documenting network, to have that view consistently across all of the network. And you've got API endpoints that you can use to pull all that data out and go use it in the rest of your tooling ecosystem, which, again, awesome, right? How does it help us specifically with the netbox problem or the source of truth problem? Going back to our original questions, this idea of initially populating netbox, what we're going to do is we're going to take the data from the discovery, that inventory data, but also any of the other data that's of use there, the IPAM information, the interface information, and so on. We've got all of the information about all the routing protocols that are running and the overlay networks and so on. So you can bring all of that data up, surface it all over the API, and use it as that initial view of the data in NetBox. But then, of course, because we're running snapshots, because we're daily having updates as to what's changed, we're able to diff those and say, right, these are the things that need to be updated in NetBox or not. And so you can take that partial view as well, and either make the change instantly, or you might choose to actually have a decision point there, right? So this is it, because this is always an interesting point. If you're going and gathering that information from the network, do you actually want it pushed back verbatim into the source of truth? Or is there a decision point to say, well, I can see these new devices, for example, should they be in the network? Or should I update my source of truth or not? And every organization is going to have their own perspective on that. In some cases, there's no way that they should have ever been connected to anything, even to power or whatever in the network, without having gone through a process. Therefore, they must have been missed from the source of truth. But in other cases, it might be the switch that someone's plugged in under the desk, right? And you don't want that at all in NetBox. You want someone to actually go and just decommission the blooming thing, and remove it from the network. So there's an interesting point there around the data that's coming through and saying, well, actually, some of this information, yes, I'll just update it straight away, but some of it I may want to take away and do something with first. So,
yeah, I've repeated that point. I think it's become part of my religion now, personally, where you never want to be populating your source of truth with data blindly, right? Tools like this are phenomenal because they'll actually present it to you in a very clear, concise format that say, here's a delta or a difference that I found. Should I, what do you want to do with it? You have two choices, right? One is you accept this as the new truth, not to sound too too,
yeah.
but and say, okay, this is how things should be. Or you say, no, that's wrong. This needs to be corrected, right? You have to resolve that delta one way or the other.
Yeah. And you can do that. You can do that with automated logic in some cases.
Yeah.
And in some cases, you really can't. You really do have to surface it as a manual process to give it to somebody to go and make that decision. So, yeah, your mileage may vary, right? But ultimately, the data's there, and we're able to at least surface it so that you know that this is a problem that you have to deal with, rather than finding a switch that's been added to the network 3 weeks later that's causing all kinds of problems that you just never knew about, right? So, it's a key point. The other one I've added on the end here is more about automation more generally. It's whether the change delivered successfully. I like this one because if you think about it, we always, when we're doing automation, we always consider we deliver a change to a device and we check that device has taken that change and that device appears to have changed in the way it needs to. The problem with most changes, it's not changing one device at a time. It's usually a change across a series of devices to deliver an outcome, right? And you change one device and it does have an impact on all of the things around it. Think of routing protocol and whatever, the idea of the distributed system again. So what we're able to do with when you have this kind of model is to turn around and say, well, actually, I'm going to verify that the whole path that I'm looking for behaves the way I expect it to as an outcome from a series of changes. And so we use the path lookup in that way, that you can basically, once you've executed your changes and run a new snapshot, you can turn around and say, actually, will this work the way I expect it to? Yes or no, and then dig down using those intent checks that we saw on the tables to say, is the behavior lining up the way I would expect it to? They're more akin to the individual device checks, but again, being able to do them en masse, you can do things like check that the routing table has propagated a route from one end to the other by looking at the entries and where they are, that kind of thing. So again, it's about having the data in one place in a normalized form. That just means that you can more quickly get to the outcome you're looking for. Right, so what I'm going to do now, really quickly, because I appreciate I'm chewing time like a good thing here. So I just want to show you an example that I've used before of using NetBox, using IP Fabric and NetBox together, and being able to update one with the other. So if you just bear with me a second. So what I have actually, let me show you very quickly. So I've actually got two. In fact, I've got three. I'm just going to unload all of these snapshots just to make it a little simpler for me. I've got these two snapshots here, which represent two stages within the life of a network, and I'll show you the network very quickly. You've already seen this one, but I can show you the changes quickly here. So day one, the network looked like this, and this is the drawing we saw earlier. And what I can do is on day two, the organization in question has acquired a new location and they've added a bunch of devices, right? So these are the devices that have been added. But of course, we don't know if that information has been then passed through and into NetBox. So if I go into my NetBox instance, which is NetBox Cloud, thanks for giving us access to this, because this has made the job a lot easier.
Absolutely. Glad it's working out for you.
That's brilliant. It's absolutely perfect for this capability. So you can see here of these devices. This L35 is the name of the organization. You can see I've got 25 devices listed here. But if I go and look at my inventory in IP Fabric and do the same, filter on L35. L35. Yep, there we go. You can see I've got 25, right? So it is all good. Now, if I go into day two, you'll see if I do the same filter, I now have 34 devices. So there's those green ones that are missing. So then clearly they're not yet in NetBox. All good. So what I'll do, what I've got here running is a script which basically listens out for webhooks. Now, IP Fabric, every time it runs a snapshot, can send a webhook to a specific location with a bit of information, and then obviously what we can do is react to that webhook. So what I'm going to do is I'm going to trigger that now. And what this script has gone and done is hit a breakpoint, which is always a good thing when you're trying these things out. Never mind.
That's how you know it's
past that. It's all live, folks. So yeah, it's from my testing earlier. So what you can see there is it's gone and hit IP Fabric. It's checked the two snapshots, and it's been able to discover the fact that we've got some added devices, right? So here are those devices, and you really can't see them very well. I should change the color of that. But these are those added devices. It's also discovered a bunch of devices that have been removed as well, interestingly, and we'll come back to those in a minute. But you'll notice as well a little WebEx Teams message popped up there on the screen while we were doing that. And what that's actually doing is giving us a bit of interaction, because it's saying that IP Fabric snapshot's been completed, that a whole bunch of devices have been added, and that we need to do something about it. So here's our check that we were talking about before. I'm not just going to go and write that stuff into NetBox. You've got to do something first in order to validate that that's what you want to do. So if I click through here, what it's done is created this web page with a list of those 9 devices that we saw before. And I now need to decide, do I want to add those to NetBox or not? Well, yes, I do, because these will represent that new location. So I'm going to hit this, and then if we go back very quickly to my script, you'll see that it's now doing some more stuff, right? It's now busy fetching devices from the snapshot, creating the roles and the devices in NetBox, and looking at the interface information that it needs to push in there. Now, as we know, the interface stuff can take a little while, but the devices, if we go back now, hopefully, should already be created. So if I now refresh this, go back to L35, I should now have well, here's a bunch of devices that are in the production site, the new site. And if I check the number, you'll see it's 34, right? So now we've created those objects in here. I go back to my script. It's just finishing up the interfaces, so we'll give that a second. And
That's
this is
very
just,
cool.
but
So that
you can see that process in underway there.
that's very cool. And I see you have the option there, so you can say, oh, like these 10 devices I expected, these other two I don't know what they are. So you're just going to put them to the side for a moment, add the ones that you as the operator say yes, this is good, and then deal with the other two some other way.
Exactly that. And as you can see, it will basically, we can select on and off. I think I toggled that one after I'd started the thing going, because it looks like it's done the 176, but I can show you on the other. So while that's doing that, what I can do as well is if I go back to the WebEx Teams message, this will eventually give me a little message on here. There we go. So it's added those devices and the interfaces for those devices into NetBox. If I go to the decommission one, I'll show you this really quickly. These are, you can see there's a whole bunch of stuff going on in the snapshots here around the MPLS network. And what I'll do here is I might say, well, actually, I don't want all those removed. Maybe they were down because of a fault or something.
Sure.
But there is one that has been removed, this P111. We can just double check and make sure it's visible in here for a start. The P111 is active in the MPLS network, yeah, and I want to decommission that one. Now, here's another case, right? So if I hit the decommission button here now, you'll see I get the message instantly on WebEx Teams. I go back now to NetBox, and if I search through on that P111, what I've done here, and this again is based on the logic, I've not removed it from NetBox, but what I've done is I've put it into a decommissioning state, so that there may be some other activity that needs to happen around that. Depends again on the organization as to what that looks like. But that
Yeah,
now
that's
being in a decommissioning state means that someone can go and do the activities they need to actually deinstall it.
that's great. So that way you don't accidentally end up, deleting a bunch of stuff out of NetBox
Right.
unnecessarily. That's danger, right?
Yeah, exactly that. And obviously the beauty of it going through all this process is it's everything is logged, right? Everything is, and you can see here in the change log, you've still got all the information there about what's been done and how it's been built. You can still see where that's come from. The script has made those changes, but it's all there and done automatically without having to manually track through and do all that stuff, keeping it all up to date. And I suppose this is the point. It's about sharing the data, right? Sorry, Jeremy, you were going to say.
Yeah, absolutely. So that script that you were showing there, that UI, that's not part of IP Fabric, I take it.
No, it's not. And this was actually this was me back in I'm right. I'm a network engineer of old, right? And I've been trying to get to grips with this network automation stuff, same as everybody else. I wrote the Python to do the things that I've shown you today. Really, because it's simple enough for it that even I can do it, right? Both the reading from IP Fabric and the writing into NetBox over the API is something that even I can comprehend. Now, that said, we have new members of the team who are busy working on all kinds of cool stuff, including a plugin for NetBox where we can start actually bringing the data in and taking much more control of the process of doing that import. So look out for that, because that's going to be awesome.
I was going to say a plugin sounds ideal for that kind of work, where you can have it, write what you want, have it just hosted there in NetBox, and it can listen for webhooks, it can make API changes, whatever you need to do right there in NetBox, and then you're really just what's great about that is you don't have to worry about, okay, how do I start a new Flask application or something like that. No, you just write a plugin, UI, and everything's already there for you. You just focus on the
exactly that, and be able to have that staging process, right? Of being able to pull the data in, stage it, say, right, actually, do I want to sync this or not, and have that all built into the workflow in NetBox, a whole load cleaner than what I'm having to do with my little middle box doing the thing, but using the same process, right? And that's the key. That it's really opened my eyes doing this kind of stuff, because the idea of having the APIs and being able to build the logic through just being able to pass structured data from one place to another changes the game completely.
Absolutely, yeah.
Jake has just asked a question there about, does it create the connections between the devices? In my script, no, but it could. There's no reason why not. The information's there in IP Fabric, so you could absolutely pull those that information through as well, because we have the relationships at layer one, at layer two, at layer three, across the board. We could absolutely create those connections as well, and pull all the IP addresses through that are in use in across the network, because we have all of the host IPs, we have all of the device IPs and everything, so we could track build the IPAM information, for example.
Especially if you were to build that out as a plugin. What's nice about that is then you're operating direct, like natively within the netbox application. You're not making REST API calls to manipulate objects, which, like, REST API is a double-edged sword, and that it can be kind of slow, but the that is in service of presenting an abstract, standardized API
Yeah,
that can be consumed by any client. Whereas if you're in Python directly, you can do anything. You can manipulate the database directly. You can express any kind of logic that you want to, because you're just working with raw Python.
yeah, yeah, and the newest member of our team has history with building stuff against Netbox previously, and you nod because I'm sure you're aware of Alex, who may well be on the call. Is very familiar to yourselves and has done loads of work in this space. So we're really excited about having him on board to sort of really move things along for us.
Me too.
And yeah, so it should be good. Should be interesting. That's pretty much all I wanted to show you. I've got another slide with some information about if people want some more information about IP Fabric. If I can share that, that might.
Sure. Yeah.
Yeah. So this is just very quickly. If anyone's interested in a lab license, up to 50 devices for 6 months, just hit the QR code or the URL. I'll make sure that you've got the URL afterwards to share. And we've got a Slack community that we're just in the process of migrating from Discord to Slack. So people joining this at a rate of knots, just really around the ideas for the use of the data, because this is the interesting thing with us. We're as much about the data as we are about the functionality of the UI, because the things you can do with that are almost limitless. So.
Yeah. And for anyone watching the recording after this has wrapped up, I'll have the links on the slide there in the comments below.
Thanks, Jeremy. Well, thank you for the time. Thank you for the opportunity to present. I know it's taken a little bit longer than I said it would do. But
this has been fantastic. Thank you so much for joining us.
An absolute pleasure.
All right. With that said, we'll go ahead and wrap up. Again, thanks for Darren Fulwell at IP Fabric for that fantastic demo. I know for myself, I'm very interested to get there and play around. We might look at setting up even maybe a community demo of IP Fabric to work in tandem with the Netbox demo and have ourselves a real good time.
Sounds a good idea. I like it. I like that.
All right, Darren. Thanks again for joining us, and
Pleasure,
everyone for watching. It was great, and catch us again next month.
Yeah. Thank you.
Take care.
Take care.